Okay, so welcome to this next video in which we're discussing endocytosis, where we're specifically looking at endocytic motifs. Right, okay, so we are now looking at how endocytic motifs were first discovered. So they were discovered by Brown and Goldstein, who were looking at familial hypercholesterolemia, which results because of mutations in the LDL receptor. When you get loss of function mutations in the LDL receptor, then it means that your removal of LDL particles from the blood is less efficient, basically, because the LDL receptor is responsible for the removal of LDL from the blood by hepatocytes in the liver. Okay, right, so the LDL particles are going to remain in your blood and build up, and since cholesterol is within the LDL particles, then that means that you're going to get too high cholesterol levels in your blood, the so-called hypercholesterolemia. Right, okay, so we've discussed that if you are a heterozygote, i.e. one of your LDL genes is broken, but the other is still working, then you're going to end up with approximately 3 times the blood cholesterol level of a normal person who has both normal LDL genes. Okay, and you generally die when you're middle-aged because of a heart attack, a myocardial infarction. Okay, whereas if you're a homozygote, if you've got loss of function in both of your LDL genes, if both of them are broken, then your blood cholesterol level is going to be 10 times what it should be, and that's very, very fatal. It will kill you generally in childhood. Okay, right. So, what we now want to discuss is what sort of mutations can result in loss of function in loss of function of the LDL gene. Okay, well, this is what Brown and Goldstein found. They found that the most common type of loss of function mutation, I think I'll go over the other side to do this. They found that the most common type of loss of function mutation in the LDL gene was that the mutation would lead to the protein just not being made, i.e. you'd suffer some mutation that would stop it being made. So maybe you'd suffer a mutation that meant that the protein was stopped. When you translate an mRNA into a protein, basically, if you've got a premature stop codon, then you're going to stop making the protein too early. Okay, so maybe that could be a reason why you'd stop making it. So stop it being made was the most common type of mutation that constituted a loss of function mutation in the LDL gene. And an example of that would be if you had a premature stop codon, which means that the translation of the mRNA would be terminated too early on. So a premature stop codon. Okay, right. So that was the most common type of loss of function mutation. The second most common type, okay, was that the protein didn't traffic properly. So it meant the mutation led to a problem in the trafficking of the LDL receptor. So maybe you make a perfectly functional LDL receptor, but you've suffered some sort of mutation to the protein that means that now, even though you've made it, it doesn't end up in the plasma membrane as it should do. Then that will lead to a loss of function of that protein, because even though you've made it, it's useless if it's in the cytoplasm. So this could lead to it not ending up in the membrane, not in plasma membrane, or PM for short. Okay, the third most common mutation was that you'd have some mutation which would change the sequence of amino acids in that protein, and this would result in it not binding to LDL. Okay, so you make the protein, it still ends up in the membrane, but it doesn't bind to LDL. Okay, and then if it doesn't bind to the low-density lipoprotein, then it's not going to actually perform its function. The LDL is going to remain in the bloodstream, and that's going to lead to hypercholesterolemia. And finally, the fourth most common mutation, which is actually very rare, is that you have some sort of mutation in the endocytic motif. Okay, and this leads to the LDL receptor not being endocytosed, so no endocytosis. So what will happen is the LDL particle will bind to the LDL receptor, Okay, so everything, well, you'll make the LDL receptor, start from the very beginning, you'll make the LDL receptor, it will go to the plasma membrane, it will still bind the LDL, but then once it's bound the LDL, it won't get endocytosed. And they looked at these sort of mutations, and they found that it was a mutation basically in the endocytic motif. So you had some sort of mutation in the portion of, in the cytoplasmic domain of the protein, the LDL receptor, that meant that it was no longer being recognized by the adapter proteins. And specifically, the endocytic motif that you find in the cytoplasmic domain of the LDL receptor was this NXXY motif, okay? And they found that one of the mutations that happens in familial hypercholesterolemia that leads to no endocytosis was that you replaced this tyrosine here with a cysteine instead. And cysteine has a very different structure from tyrosine. So when you replace the tyrosine by a cysteine, it's no longer an endocytic motif. So it's no longer recognized by the adapter protein, so you don't get the endocytosis of the LDL receptor when it binds to the LDL, so you don't bring the LDL into the cytoplasm of the hepatocyte. Okay, so that concludes this video on endocytic motifs. In the next video, what we'll do is we'll study the adapter proteins in a bit more detail.